Hey guys, welcome back to the laboratory. In this video, we are looking at the properties of molecular compounds. By the end of this video, you should be able to identify and explain the properties of molecular compounds. So, let's go. The properties of a compound are influenced by the type of bonding within it. Some compounds exist as molecules, which are a distinct group of atoms held together by covalent bonds. These substances are described as having covalent, simple molecular structures. For example, water is a simple molecular substance that always contains one atom of oxygen covalently bonded to two atoms of hydrogen. The covalent bonds between the hydrogen and oxygen atoms within the water molecule are very strong intramolecular forces. However, there are very weak intermolecular forces holding neighbouring water molecules together. These weaker forces are used to explain the melting and boiling points of these simple molecular substances. Simple molecular substances are often in liquid or gaseous states at room temperature. Remember that room temperature, on average, is somewhere between 15 and 25 degrees Celsius. If a substance is a gas at this temperature, this means that its boiling point is extremely low. Simple molecular substances have very low melting and boiling points. To change the state of these simple molecular substances, the intermolecular forces between each neighbouring molecule must first be broken. Energy is required to break these forces, and this energy is often provided via heat. Because these intermolecular forces are so weak, very little energy is needed to overcome them. The less energy needed, the lower the temperature, and thus, the lower the melting and boiling point of the substance. Simple molecular substances are also very poor conductors of electricity. This is because of the natural attraction between the positive nuclei of the atoms in the molecule and the negative electrons shared in the covalent bond. This attraction holds the electrons in place, meaning that they are unable to flow and carry the electrical charge. And remember, if any substance is to conduct electricity, there must be charged particles within it that are free to move and carry an electrical charge. Covalent bonds are also found within polymers. A polymer is a giant covalent molecule made up of a long repeating chain of simple molecules called monomers. The monomer units in a polymer are held together by covalent bonds, and its properties are determined by its chain length. For example, long-chain polymers have higher melting and boiling points. This is because longer polymers have more monomer units and therefore more intermolecular forces joining them together. More energy is required to change the state of a substance when there are more intermolecular forces within it, therefore increasing the temperature at which the polymer will change state. In contrast, shorter polymers have much lower melting and boiling points. Short-chained polymers have less monomer units and therefore have less intermolecular forces. Less energy is required to change the state of a substance with fewer intermolecular forces, therefore decreasing the temperature at which the polymer will change state. Here's an example of how you may be assessed on this particular concept. Pause the video, read the question, and take your time to answer. I'll be waiting for you on the other end with the mark scheme. This question has asked for you to explain why chlorine is a gas rather than a liquid at room temperature. As we discussed earlier, room temperature is, on average, around 15 to 25 degrees Celsius. If a substance is a gas at this temperature, this means that its boiling point is extremely low. So what does that tell us about the structure? Well, if a substance has a very low boiling point, the bonds within that substance must be very weak. We know that chlorine is a simple molecular compound, meaning that the molecules within it are joined together by very weak intermolecular forces. Very little energy is needed to overcome these weak forces and change the state of chlorine. Therefore, the temperature at which the substance changes state is very low. Your first mark is awarded for stating that there are weak intermolecular forces between the chlorine molecules, and your second mark is awarded for stating that little energy is needed to overcome these. So, how did you do on this question? Let me know in the comments section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!